This video will be covering the entire booklet of notes on rearranging formulas, what are called literal equations. Your job in this section is going to be to follow along and figure out how to manipulate these equations that contain mostly letters and very often no numbers at all to find a new variable written isolated to one side. So for example, number 1 that I have in front of you, the formula is very familiar. Interest is equal to principal times rate times time. I is equal to PRT. In all the questions that we did with this topic before, we were always solving for the interest. And I gave you the principal, and I gave you the rate, and I gave you the time. Well, in this chapter, you are going to be rearranging formulas to solve for different variables. I would like us to figure out how to rearrange this formula for P. The first thing you're going to do is you're going to rewrite your equation, and you're going to try to figure out how to get rid of everything except the letter you want to solve for. So you say to yourself, what is attached to the P and how is it attached? Right now you will notice that P is multiplied by both R and T. The opposite would be to divide both sides by R and T so that you can cancel the RT on the right. R divided by R is 1, T divided by T is 1, you're left with a P. And that's what you want, an equation with P by itself. So the principal is equal to the interest divided by the rate times the time on the bottom together. And this is a new equation, a new version of that equation. So if you were given, as you can see in your booklet, the scenario where you had $1,200 in interest, say you knew after you made a 3-year investment, you had $1,200 in interest, the time was 3 years, and the rate of the investment was 8%. And you can now work backwards and figure out how much money was invested in order for you to get that kind of a rate of an interest. Well, if I want to solve for the P, I now know that I'm going to take the interest value and divide that by the product of the rate as a decimal, 0.08, and the time. You'll recall that the time has to be written in years. So if you had a question where the time was only, say, 14 months, you would put 14 over 12 where the T is. If the time, let's just say, was 400 days, you would put it, instead of 400, that would be 400 years, 400 over 365. Let's just say the time had been for only 6 months. You would have put 6 divided by the number of months in a year, 6 over 12. So you could end up right here with your time being a fraction. So use caution. If that's the case, you would do the fraction first, change to a decimal, and then carry on. So 1,200 divided by the product of 0.08 times 3. If you need to, make sure you use big brackets. 1,200 divided by 0.24, which is going to be 5,000. So the principal invested was $5,000 in order for you to get a return of the investment of $1,200. So rearranging formulas to solve for an unknown letter, or to solve for a letter, I guess, that you're supposed to solve for. Here's example number 2. This is the formula for the perimeter of a rectangle. If we were to draw a picture of a rectangle, we have 2 lengths and 2 widths. The perimeter could be the length plus width, or the perimeter could be, in this case, the length plus the width multiplied by 2. We are asked to solve for the length. And the length, as you can see, is trapped inside of a fraction. So your first order of business is to clear the fraction somehow. In this case, we're going to do the distributive law, and we're going to rewrite without the bracket. I'm going to get 2L plus 2W. Now to solve for L, you have to get the L by itself. The first thing I would suggest is look at your equation and see if there's anything else that you can move that's not with the L term first. And I see this 2W as being quite separate and quite movable. If I took 2W and I subtracted 2W away, it would go away. But do the same thing to both sides. So if I took P minus 2W, I would get just a 2L on the right-hand side because the 2W on the right would cancel. Now I'm not quite done because my question requires me to solve for the length, not just two lengths. So now I'm going to rewrite this equation, and I'm going to solve for the lengths by dividing by 2. If I divide that side by 2, I have to divide this side by 2. And that keeps everything even. Now use caution because on the left-hand side, you cannot cancel the 2 with the 2W for the strict reason that there's no 2 with the P. So you cannot cancel these 2's because there's no 2 here to cancel with it. So the equation is going to remain, the length will be found by taking the whole perimeter. So look at this, let's go back and look at this equation. If I want to solve for one length, I'm going to take the whole perimeter. I'm going to minus this width and this width, get an answer, and then divide it by 2. And that will be the value of one length. Third example, we're looking to solve for the mass. In the formula it says density is equal to mass over volume. So the first thing you're going to do is you're going to have to get rid of the V. And you say to yourself, well, how do I get rid of that V if the V is divided into the M? So the opposite of dividing is to multiply. So if I multiply the right-hand side by V and multiply the left-hand side by V, then I haven't changed anything about the value, but I've now got my equation more simplified to say the mass is equal to the volume times the density. And that's a new equation. And this equation is actually preferable in many ways because it has no fraction in it. So for the B part of the question, when you're asked to solve for the volume, you could do it two ways. You could take the original, multiply both sides by V, and you get this equation. Or take this equation and go from there. Whoops, the volume times the density equals the mass. So I want to solve for the volume. I'm going to divide by what's beside, which is density. The opposite of multiplying is to divide. So the volume will be found by taking the mass and dividing it by the density. And that's a new equation, starting from the original equation which is giving you the density is equal to the mass over the volume. So in your booklet it asks you to find out how heavy a piece of copper would be if it occupies a volume of 250 cubic centimeters, and the density of copper is 8.92 grams per cubic centimeter. If you want to solve for the mass, you need both the volume and the density. The volume is 250 cubic centimeters. The density of copper is always 8.92 grams for every cubic centimeter. So the cubic centimeters will cancel, and you're left with a product of 250 times approximately 9, which works out to 230 if you do the rounding and all that. 2,230 grams is your mass, or 2.23 kilograms. It would be the same thing. Next formula, area is equal to pi times the radius squared, is very familiar because it's the formula for the area of the circle. If you want to solve for r, there's two things we have to deal with. The fact that the r is multiplied by pi, and the fact that r is squared. We don't want to know what the radius squared is, we want to know what the radius is. So the first thing you want to do is get rid of every term except the letter in question. So I'm going to first of all divide both sides by pi to get the pi away from the r squared. So the pi will cancel because pi divided by pi is going to equal 1. You're left with the radius squared equals the area of the circle divided by the value of pi. Now to get a letter by itself that is squared, you have to do the opposite, and the opposite in math of a square is a square root. For example, if you had 4 squared is of course equal to 16. If you want to find out what value is the square root of a 16, what you're really asking is what number multiplied by itself would equal 16, and the answer is 4, because 4 times 4 is 16, and here we go. The square and the square root cancel, leaving you with just the number. So the square root of both sides will cancel and make the radius isolated. So to show that, the square root and the square cancel each other. They're opposite operations, and you're left with the radius equals. Notice the way that I'm writing this very carefully. You take your area, you divide it by the value of pi first, treat it like a bracket, and then at the end, then you hit your square root button. So in your booklet, you were asked to find the radius of a circle if the area is equal to 100. So if the area is equal to 100, the first thing you have to do, take your 100 and divide it by pi, and then get an answer. 100 divided by pi, so 100 divided by 3.14 gives you an answer of approximately 31.8, with many digits after that. Then at the end you take your square root to get the answer, and the square root of 31.8, the radius would actually equal, when you round to the nearest tenths place, 5.6 centimeters. So remember that when you have a fraction under a root sign, you must do the division first, and then at the end take the square root. Question 5 gives you the volume is equal to the side cubed. So if we drew a cube, and we wanted to, that's not a very good cube. Oh, that's even worse. That's supposed to be a cube. Probably could have found a cube online, much easier. Anyway, the volume, if all the sides are the same length, and the length of that side times the width of that side times the height of that side, multiplied together, it gives you side times side times side, or side cubed. So quite often you will be asked in a question like this, what if you know the volume, but you want to know the actual dimension of the length of the side? So you say to yourself, what is the opposite of a cube? And the opposite of a cube is a cube root, just like the opposite of a square, square root. So let's just say that the dimension for the side was 3 centimeters. To find the volume, you would take the 3 and you would cube it. And 3 times 3 times 3 is 27 cubic centimeters. Well, what if you had a volume that wasn't so pretty and you wanted to find the side? Well, you would take the opposite of a cube is a cube root. Put your little 3 up there, and on your calculator you should check that. The cubed root of 27 is what number multiplied by itself 3 times equals 27? Well, it's 3 times 3 times 3. So the cube root and the cube cancel each other out. So remember that when you want to find a letter by itself and it's cubed, you must take the cubed root of both sides. So the cube root of the volume, now these will cancel, and you're left with the side equals the cubed root of your volume. That could be important in a question coming up where you have perhaps a sphere. Example 6, you have a formula P is equal to I squared times R. This is an electrical application. When you're asked to solve for a letter that is squared, the first thing you should do is get rid of all terms not related to the letter in question first. So we need to get rid of the R. So the first thing that I would do, rewrite the original question and get rid of the R. Well, the R is multiplied by the I squared. The opposite would be to divide. Get that by itself. You now have I squared equals P over R. We just learned with the circle question, when you find the opposite of a square, it's a square root. So we're going to take the square root of the I squared because the square and the square root cancel, but you must do the same thing to both sides. Make sure you write it nice and big from top to bottom. Therefore, to find the current, what I stands for, take the square root of the power divided by the resistance to give you the value for I. If you were going to give answers to a question requiring you to find the current, you would take your power value, divide it by your resistance first, and then get an answer, and then take the square root at the end. Now question 7 requires you to solve for x. Now x is trapped underneath a root sign, which is just like being trapped in a bracket. We've got to get rid of the bracket first, so to speak. In this case, we've got to get rid of the square root first. So our job is going to be to say, okay, what is the opposite of a square root? And the opposite of a square root is to square it. So if I rewrite the question, and I want to make that square root sign cancel, you've got to square the entire term, because the square root and the square will cancel, leaving you with just x squared plus y squared. But you must also square the other side. You're left with r squared equals x squared plus y squared. We're trying to solve for x. So therefore, we're going to have to get rid of the y. Let's bring the y term to the left and change to the opposite sign. So the radius squared minus the y value squared equals the x value squared. You were asked to solve for x, not x squared. So we have to do one more step. The opposite of a square, let's take the square root. So the square root of x squared, they can cancel. Take the square root of the other side as well. Now, great caution here. The minute you have more than one term under a root sign, you cannot cancel the square root and the square. It's got to stay exactly as written. To prove that to you, I have to show you some numbers. Let's just say we took this one, and we knew that r was equal to 13, x is equal to 5, y is equal to 12. What's the proof? 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. That's a true statement then. To solve for x, if you knew r was 13 and you knew y was 12, just as a proof, let's change that to 13 squared minus 12 squared. You can't cancel the square and the square because your answer would not equal 169 minus 144 which would equal 25, which would equal 5. If you took the square root of 25, you get a 5. If you had canceled, originally you would have had 13 minus 12. That would have given you a 1, and you would not have gotten the correct answer. That's a long explanation to explain to you why you can't cancel. Bottom line, square root square only works canceling straight up for one term only. Number 8. Notice this question has a bunch of R's, but it also has a bunch of subscripts telling you that the R's are all different. This is an example of electrical formula where you have the total resistance is equal to the resistance, the first resistance, one resistor plus the second resistor plus the third resistor. These are all different kinds of R's. To solve for R2, you would have to rearrange the formula, get the R2 by itself. Well, the R2 is attached to the R1 and the R3 only by addition. When you bring it over the other side, you're going to change the sign to the opposite. So the total resistance minus the resistance of the first minus the resistance of the third is going to give you the resistance of the second. Be very careful if you see subscripts below letters. Those different subscripts make the letters different. So don't get those confused. Question number 9 is a physics formula. Basically, it's the final velocity equals the initial velocity plus the acceleration times time. If you want to solve for the acceleration, you need to know the initial velocity, the VO, and the V, plain V, which is different than the VO. They're different letters. You got to solve for A. You're going to want to get A by itself. We should move the VO over the other side first because it's not attached to the AT term. Bring it over. The opposite would be to subtract the VO, and that would make it go away. You'd be left with AT on the right. To solve for the acceleration, you want to get rid of the T. T is multiplied by A, so do the opposite and divide both sides by the T. By the left-hand side, by the T. Make sure your fraction covers both terms on the top. Can't be sloppy. So the final velocity minus the initial velocity divided by the time would give you the acceleration. That's a new rearranged formula. Number 10 is a bit of a weird formula. You will notice that there's an E, there's an I, capital R, and lowercase r. You were asked to solve for the capital R. The capital R is trapped inside of a bracket. Therefore, your job is going to be to clear the bracket first. You're going to multiply both sides multiply the right-hand side by I. So I times R is going to be I capital R. I times lowercase r is going to equal I times a lowercase r. Your job is to solve for capital R. The capital R term is not connected in any way to this term. Let's move it over to the right-hand side. Sorry, from the right to the left and get rid of it. Bring it to the left. The E minus the I, lowercase r. Bring that over and get rid of it. Will leave you with the capital R almost by itself on the right-hand side, except that it's still multiplied by R. So your next step would be to cancel the large I by dividing. As long as you do the same thing to the other side, you've broken no rules. Now again, great caution. You cannot cancel the I on the left because the I only occurs in one term on the top. You could cancel it straight away if there was also an I up with the E, but there isn't. So you need to leave it as the E minus the IR all divided by the I. to solve for the capital R. Number 11. This one here is a good question. It will help you quite a bit with one of your assignment questions this week. I hope. We're trying to solve for m. M right now is trapped inside of one term, 1/2 mv squared. The mv squared term is multiplied by 1/2. So the first thing you should do to make your life a lot easier is to clear the fraction. And to clear the fraction, you need to multiply basically by the denominator of a 2. Because right now, m is really divided by 2. Times it by 1/2, same thing as dividing by 2. If you multiply this side by 2, that 2 would cancel, which is exactly what you want to do. And multiply that side by 2, you're keeping it even. Now in your next line, 2 times e, the 1 times m times v squared can be simplified down into just mv squared. You don't need the 1. And when you're asked to solve for m is multiplied by v squared. So you want to get rid of the v squared by dividing both sides by v squared. And that will get the m by itself. You will notice there's no square root in this question because the m you were asked to solve for was never squared in the original question. Unless your variable was squared originally, you wouldn't be asked to solve using a square root. If you were solving for v squared and solving for v ultimately, you would have had to take the square root. Number 12. P1 V1 over T1 equals P2 V2 over T2. This is a chemistry formula. It's called the combined gas law, and it's used to study the behavior of gases when pressure and volume and temperature are all variable. I want to solve for V1. V1 right now is multiplied by a P1 and divided by a T1. So the best thing you can do here is to get rid of the fractional component in your question so that you can make it less messy. So right now, if I was to multiply the left-hand side by T1 on the top, put over 1 if that helps, then the T1 and the T1 could cancel. Multiply the right-hand side by T1. You haven't broken any rules. You're left with P1 times V1 equals, put all this together in one term, P2 V2 T1 over T2. And you were asked to solve for V1. Therefore, you need to get rid of the P1. To get rid of the P1, you've got to divide by P1 to make the P1 cancel. You've also got to divide the right-hand side by P1. It's going to have to go on the bottom to be a division. Your next line then will read, V1 is going to equal P2 V2 T1 over T2 P1. And those kind of questions are a lot more fun when you're applying them to an actual chemistry question and solving for an actual volume. But we're not doing chemistry, so that's the way she goes. 13. S equals UT plus AT squared over 2. That's a 2 in the bottom. This question is quite dirty, so let's try and do it in steps. This is a really good one for catching errors in how to do things. If you're asked to solve for A right now is trapped inside of a fraction, and it's multiplied by a t squared divided by a 2, and you've also got a UT that's not even in any way remotely related to this term you want to solve for. The first thing you probably should do here is decide, are you going to clear your fraction, or you're going to get rid of the term that's not related. I'd probably take my UT and move it over here, because that would clean it up quite a little bit. S minus UT equals AT squared over 2. Now the question is not quite as bad. We're still trying to solve for A, and A right now is both multiplied by t squared and divided by 2. So thinking opposites every time. Let's now multiply both sides by 2. Because the left-hand side has 2 terms, make sure you multiply both terms by 2 so as not to just do 1/2. If I do that, I'm going to have this cancel. I'm going to get AT squared on the left. I can leave it in the bracket, or I can multiply it through the bracket. There's really no preference for one being better than the other. If I want to solve for A, I do have to get rid of the t squared. So if I do it in steps, divide that by t squared, and divide the other side by t squared, I will have my answer. A equals all bits on the left, 2 times the capital S minus 2 times UT all divided by t squared. You cannot cancel the t's because there is no t in the 2s term. Only if there had been a t in every term. There's 2 terms on the top. Could you cancel? And the last one. This is a good dirty one. There are assignment questions like this. Actually easier than this, but the same concept applies. We are asked to solve for EC. Notice it's negative. Notice it's trapped in a bracket. Not a bracket, but a fraction. Let's first of all clear the fraction. That's not that hard. If we divide, right now both sides are divided by r, by times this whole, and this whole thing, the way that it's written as a fraction like that, is only one term. It's EX minus EC divided by r. Do the same thing to both sides, times the other side by r. Now the r's can cancel. Now I'm left with a much more simplified equation. I times r, or r times I, is going to equal EX minus EC. Now EC you'll note is negative for subtract or minus or however you want to think of it. Got to get that by itself. So there's 2 steps you can do at this point. I'm going to do both. If you move the EX to the left, you're going to have IR minus EX equals a negative EC. Now the question is asking you to solve for EC. Therefore, you're going to have to divide every single term by a -1 to cancel the minus. So this is where the most common mistakes will be made. You'll be left with a positive EC on the right, a negative IR, and a positive EX. So there's your answer. I'll just change the order. EC equals, you're going to have a minus IR plus EX. Somebody else might choose to write it as EC equals a positive EX minus an IR. That would be the same thing, written 2 different ways. Now, if at this stage you would decide to do something differently, you said, I don't like that negative EC. I'm going to bring the negative EC to the left of the equal sign, and I'm going to change it to a positive, and I'm going to bring the IR to the right. So originally this was your equation. Let's just say you didn't like this because you did not like this negative. at all. So you could really, at that point, really make a choice and say, screw it, I'm going to bring this over here, make it positive, which it is, and then bring this over here and change its sign and make it minus. You'll see it's the same thing, but actually fewer steps and no trying to clear the negative number. So the choice is yours. Hope this helps seeing and hearing the explanation from the booklet out word by word instead of just reading it. There's now some practice questions on the next page. You should try those, and I'll leave those in a separate video so you can watch after you've tried them if you've made a mistake. Good luck.